My name is Joy DeBolt. I work here at SAS, and I have the pleasure of introducing your two speakers for this session, Imran Sheikh Mohammed from our wonderful partner Intel, and George Silva from SAS. Thank you both.
Good afternoon, everyone. Thanks for joining in for today's session. So today's session, we'll be going through all what offerings we have from Intel's standpoint in terms of AI and how we've partnered with SAS over the years on optimizing their applications. We'll also be looking into certain performance benchmarks that my colleague, my friend George has done using Intel's latest Xeon 6 processors to showcase the performance of AI with SAS applications. So that's something that we're going to see today. Is it more? No? Oh, okay. All right. So history of Intel and SAS is over 25 years. So we've been working closely in hand with SAS on enhancing their software, optimizing their software, and getting their products co-engineered to go to the market with unmatched performance on Intel Xeon processor. So these efforts have ensured that the SAS software is tuned to leverage Intel's latest capabilities in terms of software availability, in terms of memory availability, and also in terms of efficiency, giving the lowest possible total cost of ownership for the end users. We also have worked closely in embedding advanced AI capabilities, embedding AI into the SAS software, and ensuring that it has been optimized for Intel Xeon CPUs, all the way from generation 4, 5, and even with current generation, which is generation 6. We also have optimized the cloud-native solution, the SAS VIA, and we have ensured that by enhancing the cloud spend efficiency as well as integration and overall optimization performance from a SAS software standpoint. So next to talk briefly about what Intel envisions when it comes to the customer's AI journey. We look into the AI process as an entire pipeline and not just as a single model which has to be deployed ultimately for serving users. So you do have a data prep stage where all the data that is going to be collected, it's going to be processed, all the unwanted values are going to be removed. Then that information is going to be used for training the model. So once the model has been trained or even fine-tuned, then you go for a deploy stage. Now, Intel has you covered on every part of this journey. So starting with the data cleansing part on the AI PC that you all have in your desktops, or moving to the next level wherein you take those models and perform fine-tuning or even training from scratch using specialized hardware for data centers, be it the Xeon CPUs or the Gaudi accelerators, and also deploying it on edge to ensure lowest possible latency and without compromise of privacy for your end customers. So we are covering all the bases essentially here. And how we are doing this is through availability of the software that is going to be made free that is already available free for your developers, data scientists, and data analysts and whatnot. So Intel AI has a suite of softwares, be it Intel PyTorch extensions, be it Intel extensions for TensorFlow, Intel extension for scikit-learn, drop-in replacement for pandas. So all the regular software that the data scientists tend to use, we have them covered. And also to take it a step level more further, if we are looking at a distributed inference, distributed serving or distributed training sort of ecosystem, we have the connections between the servers optimized through the Intel's Ethernet capabilities that's available for such large systems. Moving on, introducing Xeon 6, the best CPU for AI that's available right now for consumer utilization. So the latest Xeon 6 core processors comes with two different variations, the 6900 series and 6700/6500 series. and the 120 with the 6900 series has up to 128 P-core processors. So what is that? What does it translate to you as an end user? It means more processors to perform more actions at higher frequency, and also equipped with specific accelerations for optimizing your deep learning and machine learning applications. Things like AMX and AVX512 help users realize that untapped potential that's available in the hardware from an Intel's AI standpoint. With the latest generation of Xeon 6, we also provide support for MRDIMMs, which is effectively about 70 to 80% faster than DDR5. What it means is that if you have memory bandwidth intensive applications, it's going to be way much faster. So things like HPC, things like LLM, where your next token latency is directly tied to the memory bandwidth of the given application, that is going to be performing way much better. And also, we also provide the software, support for optimizations for all the open source softwares, things like DeepSpeed, VLLM, SGLang, all the usual suspects that the machine learning engineers or the data scientists tend to use when it comes to AI. So just to slightly double click on what is AMX. So Intel Advanced Matrix Extension is actually the third generation of optimizations that we've been working on, providing purpose-built cores, purpose-built instructions available on each and every core of Intel Xeon CPU. So what it means is that all the matrix-related operations, right? Say you pick any deep learning model, that are going to be a plethora of matrix operations, matrix multiplication, matrix additions, all those operations. Typically, when not available, when using a device which is not having a AMX, it'll be getting used the AVX512 instruction set. But with AMX, you can chop those bigger matrices into smaller parts and run them in parallel at a faster pace using the tiles and the TML operation that's available through Intel AMX. And the beauty of having such things is that you can run AVX512 instructions and AMX instructions in parallel, so that I can get the best output for all the operations that happens from machine learning and deep learning standpoint. Now, AMX instructions gets kicked in when the model is using specific precision types, which is going to be integer 8, FP16, bfloat 16, and FP16 is something that we introduced from the hardware capability to be supported straight away out of the box, which is not available in the earlier generation of Xeon CPUs. Next, coming up to MRDIMMs. So MRDIMMs, like we talked about, it has a big advantage in terms of memory bandwidth speed. So regular DDR5 goes up to 6,400 mega transfers per second, and with MRDIMMs, the theoretical bandwidth that you could achieve is up to 8,800 mega transfer per second. So drastic increase for high sensitive memory bandwidth applications, specifically like AI and HPC. And in upcoming slides, we will see how this performance is translated into real-world data. So here is the rough number that you could get for various different AI models that's deployed on Intel Xeon 6. And here we are comparing the latest Xeon 6 processor against AMD's latest generation processors. And for each and every workload, be it image generation or natural language embedding generation for natural language processing, or image classification, or object detection, or even recommender system, and across each and every workload, the Intel Xeon 6 outperforms AMD when it comes to AI performance. And this is achieved through the AMX cores, AMX instruction sets that's available at each and every core of the Xeon 6 processor. Now, coming to large language models, specifically when it comes to MRDIMMs, the things that we talked about, the memory bandwidth sensitive applications, that gets heavily impacted in terms of positive performance by using MRDIMMs. And the piece of the proof is in the pudding. And that's what you see over here, that anywhere between 20% to 40% enhancements in terms of your LLM. point to note, this is batch performance numbers, and when it comes to large language models, small and medium language models up to 20 billion parameters can easily be run with Xeon 6. So much so that up to 256 concurrent users of Llama can be run on Xeon 6 for a Llama 3 8 billion parameter model. So if you want to have a setup where you have less inter-token latency, which is less than 100 milliseconds, and where you have like a decent time token for first token latency, like 1 second, Xeon 6 is a perfect fit, and you don't need to spend much for a specialized hardware just to serve few hundred users. Now I'm going to be handing over to my friend here. So he's going to be talking through certain benchmarks and performance observations that they've seen in their experiments.
Hi everyone, and first let me see if this clicker works. Let me try again. No? Well, that means I won't be walking around too much. That's fine. We're going to report about our hands-on experience using AMX, and it has been, in a way, a pleasant surprise because, like most people, we expect that AI and heavy load machine learning and deep learning loads would require GPU in every single instance, and this essentially changed our minds quite a bit. I'll touch upon some of our experiences using gradient boosting, which is one of the forms of what you might call traditional machine learning. Generative adversarial networks, that's when things start to get interesting because that's part of AI. That's the original generative AI for creating new faces of people you never saw, or of creating synthetic data, as you might see in our data maker booth. So that is a very important use case. ResNet 50s for computer vision, object recognition, etc. And BERT, which we could call this, these days I think we could call that a baby transformer, the original transformer, that was considered a very large model in 2018, and right now, not so much. But finally, and kind of our star here, is we are even able to perform inference, well, not training, not at least not for very long, but inference in large language models, at least the kind that you can fine-tune and host yourself. For gradient boosting, we're starting a little slow, but we were first very happy to see a speed up using AMX versus not using AMX. So the generation of Xeon made and the usage of the advanced matrix extension libraries made quite a big difference. We immediately see, in some cases, more than a 2 times speed up. These are for different data sets using some of our backends. So for gradient boosting, we have that in VAIO, but we provide, there's a variety of algorithmic implementations. We test a different number of them. This is the equivalent of XGBoost, and you see in multiple use cases. And depending on the data set specifics, we may even approach the performance of the GPU acceleration. So it's a nice start. But things get much better when we get to something like generative adversarial networks. And this is where the Intel extension for PyTorch makes a huge difference. This is also where the data type BF16 versus FP32 makes a huge difference. If we are talking about the back end, essentially we have a drop-in replacement for parts of PyTorch, and which are integrated in many of our VAIO algorithms. And we see that when you do variation, this is basically a convolutional GAN for generating synthetic images. And when you vary the batch size for training, the larger your batch size, the more you gain in AMX, which at some point and after a certain size of mini batch outperforms using a GPU. And that is very significant because prior to this, we were even debating not enabling the algorithm to run at all if a GPU was not present. And now we're happy we did not make that decision because it may not be necessary. For training and for inference, things get even better. So again, now we have, in some cases, the Xeon 6 architecture outperforming GPU-enabled machines for inference after a certain mini-batch size. And let me talk to you a little bit about mini-batch size and memory. When you have larger mini-batches, you occupy more memory. Memory is a scarce resource in GPUs, and after a certain amount, you run out of GPU memory and your job doesn't finish. With the Xeon 6 architecture, you are using main memory, so you are far less limited in that respect. So, similar story on ResNet 50. That's a very deep, so this is a deep neural network with 50 layers. Residual networks are when deep neural networks are worthy of the name, because before introducing of residual nets, deep neural networks would be considered deep if they had 20 layers. ResNets can go up to 150 layers easily, and that was not easy to train until this architecture came up. So right now it's part of the state of the art in computer vision and object and class recognition, face recognition, and similar tasks. We see, again, speed-ups that for BF16 can even outperform GPUs. Again, something we did not expect. And again, this is a function of mini-batch sizes. The table you see is averaged across different situations. And now BERT. This is a type of transformer. It's intended for, originally for machine translation, so natural language processing tasks. And what we see here is, number one, for training. Yes, of course, this is already a fairly large model in terms of number of parameters. We are not going to have Xeon 6 be as fast as a GPU, but it's only like 5-6 times slower, which is not bad at all, because it used to be 60 times slower, 60. So all of a sudden, we are much closer in performance for training. In some cases, being 6 times slower can be okay if your cost is much lower and if you don't have to worry about provisioning a GPU. So if it runs overnight, it's not like you have to be looking at the screen while it does its thing. But the beauty again comes when you increase the mini-batch, in this case the document size, which ends up being equivalent to the mini-batch, but this is now NLP. And you don't see an orange bar in the very last bar for training because it ran out of memory. Again, a scarce resource. So the right-hand side plot that you see is for scoring, for inferencing. And again, now you see much less difference. And in many cases, you can do mix and match. You can train using a GPU, but then you can score in production for your customers using a CPU, and again, you don't have to worry about provisioning. And the difference in speed is much less for inferencing than for training. And you see this, oh, and by the way, I did not tell you much about what kind of GPUs we used because we mixed and matched. We went all the way from really old P100s and V100s, which we would not recommend to anybody at the moment, but with the latest CUDA versions and with the latest hardware, we've been using A100s, even H100s. And that now we're talking much more seriously, and with BERT, these are A100s. So very reasonably recent GPUs. Finally, for large language model inference. So let's get real. We're not talking about fine-tuning GPT-4 here. Very few people do that. It costs millions of dollars, and we love this conference, but that would be too much of an investment to make. We fine-tuned an open source-based language model. It's actually Phi 3 Mini from Microsoft. It's a very important model for us because it's at the basis of the SAS Viya Copilot Assistant for code generation, which you may have seen in some of our demos. And by the way, there's a booth where we can show that working. It is the Copilot we use for automatically generating SAS code that we have fine-tuned ourselves with our own data. It does a very good job of knowing the SAS language. And for inference, which is, okay, we fine-tuned it, now let's run it in production. I mean, this is the kind of questions we asked it. Writing a poem about trees, what's the meaning of life, etc. And it really closely approximates doing inference on the GPU for this model, which again, very much surprised us in a positive way. So this is comparable to using A100s for inference. We have typical times averaged over different queries. For an A100, something that would take 43 seconds, and that without AMX would take significantly longer. With Xeon 6, it takes, it's maybe 20–30% slower, but that's still very acceptable. And some of these queries were larger than they need to be, and with some prompt optimization, this can be made perfectly reasonable enough to be used in production in real time. So again, this was part of our experience and hands-on tests that we do for our backtesting before we provide software to our customers. Now I'm going to pass it right back to Imran.
Thank you, George. So next, what we're going to be looking at is one of the other features that's available with the latest Xeon 6 processors. Xeon 6 processors is not a one-trick pony. It doesn't just do AI and rest of the stuff, but also from a security standpoint, we are very much into something called confidential computing. So we provide something called Secured Guard extensions and TDX. And before going into a detailed explanation of what is TDX, I just want to briefly talk about what is confidential computing and how it is very vital for customers like you. So when we look at confidential computing, we're talking about three main items. So first one is going to be isolation, wherein the code is going to be executed in something called a trusted execution environment. Right? So what it means is that you have a specific secure environment where the code is going to be unencrypted or decrypted, and apart from when the code leaves that specific environment, it's going to be all encrypted. Right? So what it means is that any sensitive data or any software or any trusted admin, only these things can be accessed. Only these things can access the code and the data when in the trusted environment, and when the data goes out of such environment, it's going to be nearly impossible for people to access such data. That is where the encryption and control comes into play. So confidential computing ensures that the authorized data users hold the key to the data. And outside the TEE, when the data is encrypted, only the authorized softwares can view it, and no other people like the cloud admins or the cloud stack or any other unauthorized software, it cannot access the data that is private for the end customers. And finally, verification. How do we ensure that the data that's out there is genuine and functioning properly? So confidential computing technology has something called cryptographic verification to ensure that the trusted execution environment is genuine and it's updated with the policy depending upon the software that you tend to use. And effectively, this process is called attestation, so that any piece of code that is going to be validated by this verification suite is always secure and confidential. Now moving on to how this is relating with SAS. So we've worked with SAS to actively test confidential computing, specifically the TDX part with the Intel. So what you see as two block diagrams is like how software would perform in an untrusted environment and one with TDX. With untrusted environment, the data and the software is going to be exposed to all the layers. So be it the cloud stack administrators or the BIOS or the host operating systems or the virtual machine guard or the guest OS. So the data and software is going to be exposed to all these parts, and so that it's going to be quite risky for people because once one of the layer is going to be compromised, all the data is free for takers, right? So we don't want to have that, and that's where virtual machine isolation with Intel TDX comes into play. The trusted execution environments that's available for free from people to use, right? So this kinds of creates an enclave around your virtual machine, around the guest OS, application, and the confidential data, so that you as end users can go to sleep confidently knowing that your data is safe and secure. And from an economic benefit standpoint, it is thrice as better by data analytics leaders to adopt such a secured environment policy, and people have observed almost 55% lesser insider threats when running an executed secured environment rather than not having one. Now, next, coming on from a saving standpoint, how much you as a customer would save adopting the latest Xeon 6 processors? So anywhere between 17 servers to one server consolidation can happen when you migrate your servers from generation 1 Xeon to the latest generation, which is generation 6, and which translates into almost 94% introduction of server count. This also means that your data centers are going to be much greener, meaning 77% reduction in carbon dioxide emissions, and also more money in your pocket to spend for others, almost 87% lesser expense. That's what you get when you upgrade to the latest Xeon 6 process from the first generation Xeon 1 process. So we talked a lot about Xeon 6, what things that it can do from an AI standpoint, how it can benefit you as a customer for using SAS on Xeon, and we also saw how it's going to be helping you from a secured computing standpoint. We'll also see one other offering from a data center standpoint on how to accelerate your deep learning applications. So we have Intel Gaudi AI Accelerator, which is purpose-built chip just to run deep learning code. So be it distributed training, be it distributed inferencing, any model that you pick out of the open source community, which is quite popular, can be used with Intel AI Gaudi accelerators, right? We are deeply working with SAS. They are validating Gaudi AI accelerators for their internal purpose, and pretty soon we will be coming out with additional information on how that test goes. But as of now, Intel Gaudi 3 accelerators is available for consumption from from IBM Cloud, as well as Denver DataWorks, which is another private cloud. So if you do have any AI models that you want to run at a competitive price performance ratio, you could get almost 1.7 times higher price performance just by porting your LLMs to run on Intel Gaudi rather than NVIDIA H100 for that matter, right? So from a form factor standpoint, we have 3 different form factors, right? The one on the left that you see is the OAM compliant module, which is built to something called Open Compute Project hardware specifications. And in any given server, you're going to be having 8 of these given boxes, 8 of the given modules as a universal baseboard. So it's going to be 8 devices, and you could use these devices to run your deep learning training or inference for that matter. If you want to go for a smaller form factor, we do have a PCIe add-in card option, which can be plugged in and played for any servers that you might want. So we have different varieties of options when it comes to device-specific AI acceleration that you might need as an enterprise.